is F202 with Wireshark, and that should run on any operating system. This is network packet analysis. So we're going to get a file called rhino.log. I'll have to download this file here because I downloaded it inside my Windows virtual machine, and I'm just going to do this right on the Mac. Let's go to Downloads and Save. And Replace, I don't care. Okay. And there it is. And if I unzip it, open with Archive Utility. Okay, now I get a case folder, and in this folder, there's the rhinousb.dd is the disk image that we were looking at in the previous project with Autopsy, and these log files are packet captures. It's an unusual file extension for a packet capture, but that's what it is. We're going to look at rhino.log in Wireshark. Wireshark is the extremely famous tool, the one you use for all analysis of network traffic. And so you can do a live capture off one of your network adapters, but what's a better way to use Wireshark is to open saved data. It's not a very good idea to capture live traffic with Wireshark because it's not very secure. You'll see why in a minute. Here's rhino.log. Open that. All right, and now you see a bunch of packets. And the thing about Wireshark is it is very smart about interpreting packets. It knows TCP, HTTP, and whatever other protocols are here. It has protocol dissectors for hundreds of protocols, every kind of network traffic, and those are just written by unpaid volunteers, and some of those are not secure, which is why it's not good to run it on live network traffic. In principle, you can get hacked that way. But on saved files, it's good. So now that we're in here, what you're seeing here is packet by packet and a summary of it. Here's a SYN/ACK to make a TCP connection to some server on port 80. Here's a GET loading. So this is a connection to a web server, and here it is downloading a page on the web server, and so on. And in the lower right corner, you can see the total number of packets, which is here 6557 packets. So 6,500 packets or so in this file. And so the first thing we're going to do is look for telnet traffic. There is telnet traffic in here, which is a really old protocol people still use that sends data without encrypting it. And now there are only 568 packets displayed. The others are not telnet. And this bar up here is called the display filter to limit what packets are visible on the screen. Now, we can export these packets and make a separate file of them. One good way to handle this, file export specified packets and save it as telnet. All right. And now we're going to save the FTP packets the same way. So I replaced this telnet with FTP for file transfer protocol. And now I have these FTP packets, and I'm going to save them, file export specified packets, as FTP. All right. Now we're going to examine the telnet traffic. So I'll close this one I'm using here and open just the telnet traffic. The thing I exported before here called telnet.pcap. Open that. And my filter still says FTP, so it's loaded, but I can't see it. I need to get rid of the filter. And now I see the telnet data. Now, here you're seeing the packets one by one, and each packet is like 60 or 72 bytes. But it's a lot more valuable to follow the stream. If you right-click one of these and follow TCP stream, you'll see the way it looked to the user. So here's somebody logging into Sun OS with a login. There's the username. There's the password. Notice it puts every letter twice because one is when you type it and one is when it echoed back from the server. And then they issued a command. Here's the login that gives them like a header. Then they did an ls-l, which lists all the files on a Linux machine. And they executed various commands here, df-k, and another login here. So you can just see what they did here. The red is what the computer said, and the blue is what the human typed in. So you can follow what this person did here in this chain of a telnet session where they're remote controlling a computer. All right. And so now there's more than one stream of telnet data here. See, this one here says stream 0. Let me, there, stream 0. If you click this, it'll go up to stream 1. Now you're seeing the second connection. They connected again and logged in again. Looks like they were not able to log in here. It didn't take their password. And so you can go here. You can go through the streams this way and see a variety of streams of data as many various things were done here. So I think there's just a flag to find in there. Yep. All right, you'll find a place where they listed files and got a file name here, and you'll be able to find a flag in one of those streams. And then you can do the same thing for the FTP traffic. So close this and close this file and open the FTP file that you extracted earlier, FTP. And now you can see here it is logging in, GNOME, FTP server ready, GNOME, password required. And you can again follow the stream to get a view that's very much like the way the original user saw it. Follow TCP stream. All right, and here you see somebody logging in. And if you change to a different stream here, should see different ones. Yep, there's another one. All right. And so again, you'll find various streams here, and they transfer some files. Like here's uploading some file called rhino3.jpg. Yeah?
Can you see also for HTTP?
Yes.
traffic?
Yes. And almost any protocol you can think of, you can do this. That's why Wireshark is very powerful. You do HTTP, you can do voice over IP traffic, you can do almost any kind of traffic.
What about on the VPN?
Well, that's a good, if it's on a VPN, then it's encrypted and you have to have the key. And as far as I know, Wireshark will not decrypt VPN traffic. You'd have to save it and use another tool. But it can decrypt HTTPS traffic if you have the session key saved somewhere. But that's tricky. That's getting much trickier than it used to be because of Edward Snowden. HTTPS traffic used to use the same public key all the time. Now it has a different key used for every session, which is called perfect forward secrecy if you're using TLS 1.3. And everybody upgraded to that when Snowden dumped out all the information, because until then it was not considered important. But when Snowden dumped out the NSA, they discovered the NSA was in fact hacking every American company and stealing their data and using this weakness to attack it. So people rushed to upgrade their security to TLS 1.2 and now hopefully to 1.3. And so then it's actually very difficult to decrypt HTTPS data. And this means people that want to secure networks at companies, they have to break all encrypted connections. They have to end HTTPS and decrypt it, and end all the VPNs and decrypt them in order to check to see that that data is not malicious. So you can't actually do end-to-end encryption out of most companies anymore. They do intercept it, which is a very important thing to know. It's a very good question. If you could have an encrypted tunnel like a VPN going out, your company couldn't control what you did. You could do anything, including violating company procedure, stealing data. You know, that's why they don't want to let you do that. And the college is blocking VPNs now too. Yeah.
Were you saying you could get hacked if you use Wireshark?
Yes, if you run Wireshark sniffing live packets, there are attacks that will take over your machine. Where I send data that's malicious. And that's because Wireshark has a whole bunch of protocol dissectors that are written by amateurs and not very well vetted. It's just like Firefox has all these extensions, and some of them are not very safe either. And for that matter, so does WordPress. If you add a lot of extensions, you usually get hacked before long with WordPress because the extensions are written by amateurs. And you have to be very careful and only put on trustworthy extensions. And if you put on sloppy ones, then they have vulnerabilities and you get hacked. Yeah. That's why the best way to do network monitoring is to use a tool like TCP dump that does not interpret the traffic, it just saves it, and then later use Wireshark to analyze the saved packets. That's much safer. Good. These are good questions. And let me see what else you have to do here. So you'll find flags in here. There's a flag in the telnet traffic. Yeah. In the telnet traffic, there's a list of files, and you find a file name in there. You get this screenshot, and the file name is the flag. And there's also, in the FTP traffic, there's a file name after contraband.zip. And then you can extract images from the FTP data traffic. So let me do that. If you get out of this and open the original Rhino file, close. Open the original rhino.log. All right, and get rid of the filter. All right, let me scroll down here in my instructions. All right, now we can look at the FTP data file. See, FTP files that we looked at before contain things like the username, the password, and commands like upload a file, download a file, but the actual data that moves is in a separate protocol called FTP data. And there it is. And notice the previous packets were pretty small, like 60 or 70 bytes. These packets are all 1,514 bytes, which is the maximum, because this is where it's moving a lot of data. And see, here it is, moving this file called rhino1.jpg, which takes many packets to move that file. So here's the data, and they want to put this in a separate file. So I export as FTP data. And then I open just that file. All right. All right, might as well get rid of that filter, it doesn't matter. All right, and now I want to follow the TCP stream here. And now what you've got here, this is what an image looks like when viewed as a raw text document. You'd see the same thing if you open an image in Notepad. And notice part of it is readable. Adobe Photoshop, and this JFIF at the start, that's part of the file header. Every file, almost every file type, has a header or a footer. And the header usually contains some readable parts so you can identify it. So this is what JPEGs look like. They start with JFIF. And so this is what a raw image looks like. You can't view it this way, but you can extract the image from there. And the way you do it is you save it as raw. Down here, you can save as, and here, well, I have to show it as raw first, pardon me. Right now it's showing as ASCII, which is printable characters, is not what I want. You have to change this to raw. There. Now you're seeing the raw hexadecimal values of all that, and now you can save it as, and give it a name like rhino1.jpg. And now that you've saved it, you can open it. Go to the case 1 folder where I saved it. Here's rhino1.jpg that I just created, and when you double click it, it'll open, and there's a picture of a rhino. So that's how you take network traffic and extract files from it. There are various ways to do it, but this process is extremely valuable for a forensic person to know. FFD8 is the binary header of a JPEG image, and it will also have the readable text JFIF, which is, I think, these letters here. This is the raw hexadecimal version of it, and you get used to this, seeing files in hex view and also in text view as you learn to spot various kind of files. This process is called file carving, where you look at headers and footers and find a file, although in Wireshark is doing it for us right now, so we don't have to do it manually. And Autopsy will usually do it for us. But that's how it can pick files out of unstructured data. And there's a couple flags to find here. You get the MD5 hash of that Rhino file to show that you've got it. And that'll be the flag of that one. And then there's a zip archive. You'll find if you go to the other streams, you'll find a zip archive instead of an image file, and then you'll have to unzip it, and you have to crack the password. If you are taking the pen testing classes, you'll have some practice cracking passwords. If not, you can just skip this. That's why it's extra credit. It involves information that's somewhat outside the course. But anyway, it's kind of fun to learn how to crack passwords. And all right, that's it for that one. Let me stop the recording, I mean.